If you're into wiring your own projects and doing your own repairs, it's really useful to know how to use a multimeter or voltmeter, like this fluke meter here. Do you remember how last year, I think, we were able to use one of these to fix one of your toys? What was that?
An excavator.
And we found that it was broken by using this voltmeter. Well, now let's show everybody how a voltmeter works. I think you guys put together a mystery circuit for me to diagnose using this voltmeter.
Yes. Here it is.
Thank you. So what is this circuit supposed to do?
That's what you'll have to figure out. It's a mystery.
I can't argue with that. First, we should explain the parts of the multimeter. This knob lets you select what you want to measure. The V with a straight line indicates DC voltage, and the V with a wavy line indicates alternating current. Direct current is electricity that flows in only one direction, like the electricity that comes out of a battery. Our homes, on the other hand, are wired for alternating current, which changes direction many times every second. Continuing down the dial, we see the setting for measuring resistance, shown here by the omega symbol. Then there's the setting for measuring alternating current, not voltage, but current, which is done with this clamp here. Since we're running off a battery's direct current, we won't demonstrate that today. Here is the off position. The hold button freezes the display reading, and these jacks are for plugging in the probes that will touch to different parts of the circuit. We attach them like this. So let's see about this mystery circuit. The first thing I'll check is to see if the batteries have the voltage that they're supposed to. Make sure the boys didn't trick me by putting in batteries that don't provide the right voltage. You wouldn't do that, would you?
No.
A big difference between a higher end multimeter like this one and the less expensive models is that you don't have to specify the range of the voltage. The fancier models are auto ranging. So we can go ahead and set the dial to DC voltage and measure the voltage without setting the meter to a specific voltage range. We can start by measuring the voltage across the battery pack. The meter will read 3 volts. There it is, which is what we would expect of 2 AA batteries. Each AA battery is of 1.5 volts. So together we get 3 volts. Typically, you touch the black probe to the negative side of the circuit and the red probe to the positive side. However, on this multimeter, it doesn't matter. It will work either way. If we connect the probes in reverse, the black probe to the positive lead and the red probe to the negative, we measure negative 3 volts. Next, we can use the multimeter to measure resistance. We turn the dial to the resistance setting. With an inexpensive multimeter, you'd have to also specify a range. We can start by measuring the resistance of this resistor in the circuit. Since this circuit was built using Snap Circuits components, the resistor is clearly marked as a 100 ohm resistor. So we'd expect the reading on our multimeter to match. If we touch a lead to each end of the resistor, sure enough, we see the reading. It says 102.5 ohms. That matches the expected resistance. We can use the resistance setting to do more than just measure the value of a resistor. We can also use it to test continuity in a circuit. Just like in this case, where we expect there's a break somewhere in the circuit, we can measure resistance at different locations in the circuit to home in on where the bad connection is. Where resistance is low enough to allow electrical current to flow, the multimeter will beep. Where there's a break in the circuit between the probes, the multimeter will not beep. So let's see, since this is one piece, I'm pretty sure there's continuity. Now, these are 2 pieces that connect and, oh, That's good. How about all the way over here? Good. In fact, I can just walk along the circuit to there, so I know that's all good. Let me check to see if this line is connected. It is. And I can see this should be connected around here. And it is. That's good. That's good. Oh, now that one's not making any noise. But that one is good. So I think it's the connection between this and the bar below that's not working. Let's see. If I pull this up, oh, somebody put tape on it. I bet if I take off this tape and then reconnect it, the circuit will work. Now let's see if that fixed the circuit.
We left in it for your birthday.
Oh, that's right. My birthday is coming right up.
Happy birthday!
Thanks, guys. We hope you'll join us again next month when we'll be wiring up a Christmas ornament that talks when you get close to it. See our website at geekpackhack.com for info on parts and project guidance for adults. Please leave us a comment to let us know what you think, and send us your ideas for wacky hacks. If you enjoy our show, don't forget to subscribe and give us the thumbs up.